subscribe and press this bell icon to never miss another lecture video. Hi, welcome to GATE ESE lecture. We are in the 13th lecture of signals and system, and this is your second module, that is discrete time signals. And in this video lecture we are going to actually start our second module, that is your discrete time signals. And in this video lecture we are going to understand the definitions and the simple introductory points of from discrete time signals. There are a couple of various simple terminologies that we are going to discuss here in this video lecture, and from the next video lecture we'll get into the core analysis of discrete time signals. Now this video lecture is very important for you, because here we are going to give you the fundamental clarity about discrete time signals. Now let's start with the discrete time signals. What is a discrete time signal? Basically, discrete time signals are nothing but the function of discrete independent variable. This terminology is very important. Discrete independent variable. Lots of people does have this communication gap problem when they are asked what is a discrete time signals. You need to say this thing in a very simple way, that is, discrete time signals are nothing but the function of discrete independent variable, and independent variable are divided into uniform intervals, and each interval is represented by an integer. It's not a rational function, it's not a rational number, it is an integer, not a real number, it's an integer. Okay, and the letter n is used to denote the independent variable, and it is denoted by discrete time signals denoted by x of n. Now let's get into the detailed analysis of this definition. Through discrete signals can be generated in three ways. So let's discuss this definition through these three ways. Now what are these three ways through which that we can actually define discrete time signals? Now the first way is generate a set of numbers and arrange them as a sequence. That means what? You need to generate a number like 0, 1, 2, 3, 4 up to n-1. Why n-1? Because we have included 0 here and we are counting this also. Okay, so if there is a train of numbers which got generated and this forms a ramp like sequence, now this can be represented as x of n equals to n, where n belongs to 0 to n-1. Okay, so this is one way of representing. Second way of representing is by providing some evaluation on numerical recursion, like x of n equals to x of n-1 by 3. Now through this formula, like this is a kind of numerical methodology which is provided. Okay, now it is given key initial condition x of 0 equals to 1, and this will lead us to a sequence. This will lead us to a sequence which is nothing but x of n equals to 1 by 3 to the power n. So nahi samajh mein aaya? Okay, let me clarify this thing. Look here carefully. It is given, so that means it is saying ki x of n equals to x of 0, x of 1, x of 2, like up to x of n. Now look here carefully. Here x of 0 means x of 0 is given, that is 1, that will become 1. So instead in place of x of 1, if you find out x of 1, what will it come out to be? X of 1 means x of 1 minus 1, that is x of 0 by 3. X of 0 is 1, so 1 by 3. Okay, similarly if you found the x of 2, it will give you 1 by 3 ka square, similarly 1 by 3 ka cube, and so on. Now these functions can be represented x of n, so that means I can write it down, x of n equals to 1 by 3 to the power n. Now this is the evaluation of numerical recursion. This is a second way of representing discrete time signal. So clear, this is the second way of method of representation. First way is generate a set of number and sequence, and you just need to write it down what is the sequence it would be. Now the third method is sampling. Now this is a uniformly sample a continuous time signals, and using this amplitude of the signals to form a sequence. signals. Now let x of t can be continuous time signal. Now the discrete time signals, for this thing you just need to replace t in place of t, the thing what we have written here t, no, you need to replace this t by nts. Okay, now what is n, what is n, you know that number of samples that is just divided, and ts is your sampling time. We'll just get into those concepts, but यहाँ पे मैं बस आपको this what are the different terminologies, what are the different methods through which that we can generate discrete time signals, that is what I am explaining to you. We'll get into detailed analysis of all these concepts. Okay, बिल्कुल confuse मत होइए. Now see, this is your continuous time signals and its subsequent discrete time signals which get sampled for each and every time instances. It is represented like this. Okay, there is different sampling point which got sampled. How it gets sampled? Because we just replaced, in place of continuous time t, we replaced it by n into ts. What is n? N is the number of samples and ts is the sampling time. We'll get into what is the sampling time. Now let's get into the sampling phenomena. What is the sampling thing? Now sampling of a continuous time, we'll get into detailed analysis of this thing. This is very important topic. This is a very important topic of discussion, because it leads to a major part of communication engineering. Okay, now just listen to this carefully. Sampling of a continuous time or analog signal, this is nothing but sampling is a process of conversion of continuous time signals to discrete time signals. और कुछ नहीं है, बहुत ही सिंपल चीज़ है. continuous time signals है and you need to convert it to discrete time signals. So sampling is the process in between these two. Okay, that means through the sampling process we can convert a continuous time signals into a discrete time signals. और कुछ नहीं है concept इसका. ठीक है, clear? Now we usually take definite interval of time and do the samples, and when the time interval of two successive samples is same, that will be called as uniform sampling. Now if the sampling time interval between all of these time gaps or these samples are same, then that will be regarded as uniform sampling. And that time interval in between these two successive samples, for example, this is t1 and this is t2 minus t1, this time is your sampling time, that is your ts. The ts that I was saying to you, no, that ts is nothing but your time interval between two successive samples, and 1 by ts will be regarded as sampling frequency. That is, the reverse of sampling time is known as sampling frequency. What are the terminologies that we have learned? Uniform sampling, sampling time, and sampling frequency. What is a sample? And three methods through which we can generate discrete signals. अभी तक के लिए हम लोग ने इतना तक पढ़ा है. ठीक है, now let's get into थोड़ा मज़ेदार concept के अंदर. Now look here carefully. Sampling of an analog signal. What does that mean? Listen to this carefully. This is very important. When you have a continuous time signal, okay, continuous time signal, that means if this is a continuous time signal, it's a time range, it's a frequency range. If you reverse this value, it's a frequency range. As you can see, it is ranging, the frequency range of continuous time signals are mapped to or converted to finite range. So basically in continuous time signal, your frequency range is minus infinite to infinite, like it is unlimited. Now what if this is the condition? And the benefit of discrete time signals are, we through sampling we can convert this time interval of infinite duration to a definite interval. Clear? कोई एक इनफाइनाइट टाइम इंटरवल के गैप को सिंपल बात में बताऊं तो कंटिन्यूस टाइम सिग्नल्स के फ्रीक्वेंसी रेंज इन्फिनिटी होता है. तो बट डिस्क अगर इसको हम लोगों ने सैम्पल किया, सैम्पलिंग के प्रोसेस से वी कैन डाउनग्रेड और वी कैन मैप इट टू सम डेफिनाइट इंटरवल लाइक -a to a, कोई एक डेफिनाइट अमाउंट ऑफ इंटरवल के अंदर इसको हम मैप कर सकते हैं. माय डियर फ्रेंड, दिस इज वन ऑफ द मोस्ट इम्पॉर्टेंट पॉइंट एंड वेरी इंपॉर्टेंट फॉर योर इंटरव्यू क्वेश्चन. What is the benefit, the basic core benefit of sampling of an analog signal? That is the infinite frequency range of continuous time signals can be mapped or converted to finite range discrete time signals. Clear है ये point? Now let's get into the core analysis of sampling. It is very important. Lot of people does have this confusion like for lifetime. So I want you to give you clarity on this kind of analysis. Listen to this carefully. For example, there is a continuous time signal which is given as cos omega naught t plus pi. Now if you want to sample it, you need to replace t. In place of t you need to replace nts. So similarly in this t you have replaced nts here, where n is number of samples, ts is the sampling time. Now this value is nothing but if I convert it ts to 1 by fs, it will be okay. Fs will be sampling frequency. It can be written like this. And this omega naught, look here carefully. This omega naught is nothing but 2 pi f naught, where this f naught, this omega naught, this I'm talking about this omega naught, okay, where this f naught, look here carefully, where this f naught है ना, ये जो f naught आप देख रहे हो ना, this is the frequency of this continuous time signals. Okay, now this fs is the frequency of the samples through which that we are doing the sampling. ओके मतलब हम लोगों ने मान लो एक डिवाइस रखा जिसका सैम्पलिंग रेट है fs, समझ रहे हो, और ये f नॉट है मतलब गिवन कंटिन्यूअस टाइम सिग्नल का फ्रीक्वेंसी. क्लियर होना चाहिए. एंड इफ यू डिवाइड दिस f नॉट बाई fs, जो हम थर्ड स्टेज में करने वाले हैं, लुक हियर. Now if you divide this f naught by fs, that will give you, like, instead of f naught by fs I am writing down like small f naught. Now this f naught is your discrete time ka frequency. Clear with this concept? This omega naught contains capital F naught. This is your continuous signal like sinusoidal का continuous time domain का frequency है ये. Clear है? This fs is your sampling frequency, and if you divide f naught by fs, n को इधर ले आओ, f naught को इधर ले जाओ, ठीक है, and f naught by fs, that will be like, instead of writing f naught by fs I can write down your small f naught. Now this is nothing but your discrete time signal का frequency, discrete time signal ka frequency. Now I have just wrote it down here. fs is your sampling frequency, f naught the frequency of sinusoidal signal, capital F naught. This capital F naught is the frequency of sinusoidal signal, continuous sinusoidal signal, which is ranging from -infinity to infinity. This is a very important point, which is ranging from -infinity to infinity. But this f naught by fs, this f naught, if you get into this f naught is nothing but f naught by fs, and this is a frequency discrete sinusoid in cycles per sample. This represents your cycle, number of cycles per sample. 1000 of questions गेट का यही टर्मिनोलॉजी से आपका सॉल्व हो गया. मोस्ट ऑफ द क्वेश्चंस आर आस्क्ड फ्रॉम दिस लाइक थिंग. 3 टर्मिनोलॉजी है, एक कंटिन्यूस टाइम डोमेन का फ्रीक्वेंसी है, और एक आपका डिस्क्रीट टाइम आपका सैम्पलिंग रेट है, और एक आपका डिस्क्रीट टाइम का फ्रीक्वेंसी है. 3 फ्रीक्वेंसी को आपको याद रखना है, ये एक एंड दिस वन. एंड दिस वन इज एक्चुअली मतलब राजा है. दिस इज अ किंग ऑफ अदर फ्रीक्वेंसीज. दिस इज नथिंग बट द साइकिल्स पर सैम्पल्स, एंड दिस इज रेंजिंग फ्रॉम -1/2 to 1/2. Ari, sir, continuous time signal was ranging from minus infinity to infinity. So when we converted this continuous time signal into discrete time signal, sir, it is ranging from -1/2 to 1/2. कैसे हुआ? We are going to study about this concept in the next video lecture. Okay, but keep watching gel video. Do subscribe to this channel, my dear friend. I'm doing a lot of work, lot. We are 10 number of people. We are working day and night to provide you a beautiful contents which is having extremely beautiful clarity. Okay, so please do subscribe and do share with your friends, and please have a clarity on this capital F naught, small f naught, and this fs. Okay, go through this notes will be down in the description. Thank you so much for watching this video. See you in the next video lecture where we're going to discuss कि कैसे ये -1/2 1/2 हो गया, infinity से infinity का frequency range. Okay, till then, bye.